Hi, in this video I'm looking at this derivative here where we're doing the derivative of inverse cos of 7x or arccos of 7x. Now an inverse cos function, the derivative with respect to x of inverse cos is given of x over a is given by -1 over the square root of a squared minus x squared. Now, I haven't got x over a, I've got a number times x. So the first thing I've got to do is sort out what is a, so I can correctly do this derivative. So if 1 over a is 7, because my x over a should match up with 7, then that means that if I multiply both sides by a, I get 1 equals 7a. So that means that a is 1 over 7. So when I go to perform my derivative using this pattern, I use a's 1 over 7 rather than just 7. So let's go and start putting this in. So I've got equals to the -1 over the square root of my number a squared. But a is this 1 over 7, which is squared, minus of x squared. So now we know what we need to do is tidy up this 1 over 7 squared and get it as neat as we possibly can. So if I think about this, I've got -1 over the square root. And if I think about factorizing that 1 over 7 squared out. So if I think about, I've got 1 over 7 squared, and I'm going to try and factorize it out of the rest of this expression. So that means that 1 over 7 squared divided by 1 over 7 squared is going to be 1, minus, well then we've got the x squared, and it's got to be divided by 1 over 7 squared. So I'm going to divide by 1 over 7 squared. Now, the reason this is helpful to us is that because I've now got this 1 over 7 squared being square rooted, I can bring it out the front of the square root. I can actually do it square root. So that gives me 1 over 7 outside of the square root, because the square root of 1 over 7 squared is 1 over 7. Outside the square root of 1 minus x squared. And if we think about this 1 over 7 squared, 1 squared is 1. And 7 squared is 7 squared for now. We'll just leave it as 7 squared. So I've got -1 over 1 over 7 square root of 1 minus x squared over 7 squared. Tidying this up some more, I've got -1 over the square root, and now this whole thing is being divided by 1 over 7. I'm going to bring out that over 1 over 7 and turn it to divide by 1 over 7, because a fraction means divide. And then I've got 1 minus x squared, and I'm going to do the same thing with my 1 over 7 squared. So I'm going to divide by 1 over 7 squared. So now I've got -1 over the square root of 1 minus. Now a divide with a fraction means that I've got x squared multiplied by, flip the fraction, 7 squared over 1. I'm not going to bother with the over 1. And that means I've got the same here, multiplied by 7 over 1. So I'm not going to bother with the over 1. And so now finally sorting this out, I've got -1 times 7, which gives us -7, over the square root of 1 minus, and I've got x squared times 7 squared, so that means that I've got 7 squared x squared. And the last thing I can do is join the 7 squared x squared together, And that gives us negative 7 over the square root of 1 minus bracket 7x all squared. And that's the answer to our derivative. The derivative of inverse cos of 7x using this rule for doing our derivative of inverse cos of x over a becomes negative 1 on the square root of a squared minus x squared. And doing a bit of playing around with fraction mathematics gives us negative 7 over the square root of 1 minus 7x squared. Now that was a fair bit of work doing it that way. But we can actually do this a second way. So if I go back to my original question, where I've got the derivative of inverse cos of 7x, I can, instead of deriving directly with this rule and then playing around with some fraction maths, I can use a bit of a chain rule. So I can let u be 7x and then derive u with respect to x, and derivative of 7x with respect to x is just 7. So now applying the chain rule, my derivative is going to change to d du of the inverse cos of u times by du dx. So I changed my chain rule. So now I can derive my inverse cos with respect to u using this same rule we had up here, but a is just going to be 1 because I've got over 1. So that means that this becomes d du of the inverse cos of u is going to be negative 1 over the square root of 1 squared, which is just 1, minus x u squared. So I'm going to have minus u squared. And then I've got to times by du dx, which we said was 7. So I've got, instead of cos inverse u, that derives down to negative 1 over the square root of 1 minus u squared, all times by du dx, which was 7. And so now if I tidy things up, negative 1 times 7 is negative 7 over the square root of 1 minus, and I've got to replace u. And u is 7x, so this is going to be 7x squared. So there's two ways of doing the same problem. I can just apply the rule directly, but that means I've got to do a bit of playing around with fraction mathematics to get to a nice, neat answer. Or I can treat this as a chain rule question and replace this internal function. So I've got a function of a function. I've got the inverse cos as one function, and inside it, I've got 7 times x, my second function. So that means chain ruler. So I derive u, change my question to d du of the inverse cos of u times by du dx, do those derivatives, sort out the mess, and I'm done.